volume of revolution. Volume of revolution means like this. We have a curve y equals to fx. Can you see this uh, red line? This red line is called y equals to fx. Okay. Now this part y equals to fx bounded by enclosed by this line y equals to fx, x equals to a, and x equals to b, and it will form an area. This is the area under the curve. Now when this area under the curve is rotated about the x-axis, it will form something like a cylinder, not a cylinder, something like a cone, right? A cone with one part chopped off like that. Can you see this like that? This area. Now this area, the dotted one, the area is rotated about the x-axis. When it is rotated about the x-axis, it will generate a volume, and we can actually find this volume, right? If the curve is uniform, we know the equation of the curve, you can actually find the volume. Maybe you see the reservoir there. They built the reservoir like a curve like that. Then they know how much water is there, how much is the pressure of the water there, and they have to build the wall according to to withstand the pressure, the volume of water pressing against the wall there. Okay, so we actually can know the volume of water. Okay, so this part is rotated about the x-axis. So what can you say? Okay, we read here, read here. Okay, on the top left hand corner there, I read volume generated when the area bounded by the curve. Maybe I stop first. The area bounded by the curve x equals to a, x equals to b, and the x-axis is rotated 360 degrees about the x-axis. So when you're rotated about the x-axis, like what I'm doing now, right? This one, maybe this one, I don't know. Maybe this, like that. Okay. So what they are trying to say is that this area here, this area here, okay, this area here, area bounded by the curve, the top line, x equals to a, the yellow line, x equals to b, the yellow line, and the x-axis, this black line. So this trapezium is rotated 360 degrees about the x-axis, and the volume generated is, if it is the x-axis, it is by y squared dx. It's always dx, right? So you have to get the value that from the x-axis, x equals to a, x equals to b, then dx. Even the y square, you have to change to x. Even the y square, you have to change to x. And pi is the constant, just like our area of circle by r squared. There's always a pi there. So when you move in the circle, there's always a pi there, right? So this pi is a constant, and you can take it out. Okay, so we're going to look at the volume generated. I read from the top left hand corner. Volume generated when the area bounded by the curve y equals to a, y equals to b, and the y-axis is rotated 360 degrees about the y-axis. It means that this area here between the curve, right? This is the line curve. The yellow line, y equals to a, y equals to b, and this axis here, the y-axis blue. Now this area is rotated about the y-axis. When it's rotated about the y-axis, you will get something like a cylinder. It's a cone, like a cone like that, with the bottom, the sharp part cut off. Okay, so it will generate a volume. This, when it rotates about the y-axis, it will generate a volume. So what is the volume of this? What is the volume? How to remember the formula for the volume? Okay, the formula, if it is rotated about the y-axis, actually everything is in terms of y. If it is rotated about the y-axis, everything is in terms of y. Now let me explain. The limit first. This is y equals to a and y equals to b. Now let me explain here. When it is y, then it's y equals to a and y. This is y equals to a. This is y equals to b. And about y-axis, it is dy. Of course, before you substitute the formula inside is by x squared dy. Now you cannot integrate this x with respect or x squared with respect to y. So you have to change this x squared into y. X squared, you change it to a function of y. Right? Then you can integrate. Any questions so far? Now I ask
No,
Chen Tong.
teacher.
Li Ying got no question. Chen Tong got question or not? Can understand or not? Oh, Chen Tong, okay, right? So if okay, then I move on to one example, right? We're going to move on to example, right? Okay, so ayo, I didn't put the eh, I didn't put the click 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 there. Never mind, you don't look at the other parts. I show you here, then you look here. I use the green tick there. I use the green tick. Now I am here, the green tick at the top right hand corner, left hand corner. Find the volume generated for the following diagram when the shaded region is revolved through 360 degrees about the x-axis. Okay, so I am at this diagram given by the book, the diagram given by the book first. Okay, now in this diagram, this is a parabola and there are two shaded regions, one here and one here, but they are very kind. The two shaded region, they are connected, so you can integrate straight from -1 to 3, -1 to 3. Now unlike the area, you have to break it up into two parts, one positive and one negative, then you add them together, right? But in volume, you don't have to break them up, you just integrate straight away because of the square. When you square, everything become positive. Okay, I think we continue the next lesson.